Welcome back to my channel. My name's Brian Kafka, and this is a continuation of my interview with deep dive Apache Spark and Databricks expert Daniel Zafar. We'll be discussing new Spark features and really the ones that Dan's most excited about. Again, a little refresh. Dan basically works with the largest customers at Databricks, solving their problems. So he knows everything there is practically on Apache Spark and Databricks. So when he talks about new Spark features, you're going to learn really what's cutting edge, what's coming out, and what you should be focused on. He also has a really interesting insight onto machine learning training and a lot of exciting things going on in that domain. Now, one thing that may surprise you is Python is the most popular programming language on Apache Spark by far. That's an important thing to say. The question you may ask is, how does it perform? Is it really equal to the native language Scala? Interesting questions. So he talks quite a bit about that, and I think you may be surprised to find the answer. I think this is probably the sweet spot, if there's any, for Daniel, because this is what he does, right? Things you should do. That's the stuff he has to go into your messy code and solve. And then the things you should not do. Those are the things you do, or I might do, that I didn't know any better, that he has to come in and fix. So this is a really interesting spot. Certainly something you want to listen to as we get into more fascinating discussion with Daniel. I was going to ask about pros and cons of Snowflake versus Databricks, but I think you kind of answered that. I think because Databricks is coming from more a landing point and then layering different ways to process the data, that's kind of its strength.
Yeah, one thing that I didn't mention though is with Spark 3, which came out in the last year or so, Databricks is faster than Snowflake. Sorry, I feel like a sales guy, but yeah, it is faster, which is nice. I would say if I needed to give some sort of pros on the other side for Snowflake, I would say I believe they've really done a good job on sort of with the UI and simplicity, and that's something that at Databricks, it's been number one focus, make Databricks super simple, because traditionally we were sort of the company of the data geeks, the people like the hardcore software engineers, full stack, sort of developers would be writing their distributed code on Databricks. And so Snowflake, I mean, there's a lot more SQL analysts than there are, hardcore software engineers, right? So they all went straight to Snowflake because they could just write SQL. So Databricks is definitely that's the main thing that we're working on.
Mm-hmm. Okay, great. Makes sense. So what architectural and technical enhancements to Spark do you see that you're most excited about?
Yeah, good question. I think in terms of core Spark, in terms of open source Spark, I think I'm excited for more machine learning models coming out. There's been less activity on that side. I'm also really interested in seeing, this is more of an open source thing, but a lot of people are using XGBoost, and the ability to run XGBoost in PySpark in distributed manner on PySpark, I'm really looking forward to. That's something that's requested quite a bit. What else? I think further integration with tools like TensorFlow is really nice. There's other open source projects that do that. Like for instance, if you're sort of a machine learning engineer and you haven't checked out Petastorm before or Horovod, those are two projects from Uber that are super cool. What Petastorm does is it basically will stream data from Parquet files into your TensorFlow model or your PyTorch model. So additional sort of functionality on that side. Again, it's not core Spark stuff. This is like open source projects. And then in addition to that, I'm really excited for just Delta progressing, becoming more mature, more stable, more open source connectors, because yeah, Delta is super cool. It's really powerful. It has a very similar feel to Spark, because you can run sort of these, you can run these commands, like for instance, like merge, upsort, all of those on your Spark tables. That's amazing for so many
It's
people.
really good. Yeah. And I saw the merge statement. I was like, that's awesome.
Yeah,
It's extremely
yeah.
useful. Yeah.
People love it. Yeah.
Yeah.
Also, funny tip. It also basically does a dedupe job to the merge. So that's a good thing to note for people out there that are doing streaming stuff. If you're worried about duplicates coming in, if you just do a merge, you can set it to just drop the duplicates. So
Cool.
Yeah,
That's good. Microsoft has that on SQL Server merge, but most DBAs say don't use it, don't use it. It's got bugs, and they don't like it. I've used it, but it sounds like on Spark it's pretty foolproof. Works well.
Yeah.
Nice. All right, so kind of along similar lines, but do you have any favorite features of Spark currently that are there that you say this is an awesome feature? Koalas, it sounds like one is that you like.
Yeah, I wish I'd have time to dig more into koalas. I haven't used it a ton, but I think, by concept, it's really cool. I gotta say, I think in terms of just core Spark, my favorite stuff, I would say my favorite thing to use is definitely Pandas UDFs. Have you used those before?
I have, yeah. I mean, I covered them in my book, but it
Right.
seems like with Apache Arrow, they're particularly good. Like that enhances the performance, right?
Yeah, we can talk more about that later on, but
Yep. Yep.
yeah, with Pandas UDFs, the speeds that you can get are just astronomical. It's
Yeah,
absolutely insane.
which is really
So,
amazing because I expected them to be horrible for performance when I started
mhm,
with that. Yeah.
mhm. But with Arrow, it just takes it to another level. Like there was a really interesting post by Reynolds Zinn, who's one of the co-founders, and he said, with Spark 3, now that we have these sort of Arrow Pandas UDFs like super dialed in, um, traditionally when PySpark first came out, people were like, "Oh, it's going to be slower. You want to avoid it," and like Spark 2 and stuff. And then if you have some sort of UDF, you should just code it in Scala or code it in Java or something so that so it'll be faster and it doesn't need to spin up the Python REPL and spin down the Python REPL. But now with Arrow and Pandas UDFs, you can get it faster in a Pandas UDF than you ever could in Scala.
Interesting.
So
Okay.
it's really interesting. Yes, it's
Yeah.
super cool.
Yeah. No, and it's counterintuitive because you don't expect that. You'd think, oh no, you're using Python, it's going to be worse. But
Yeah. But yeah,
right,
the
so
APIs of like map in pandas, apply in pandas, then tuning the sort of max records per batch. There's like
yeah,
a config there where you can sort of tune like how many get vectorized at once and get sent as batch into the data frame. Super powerful stuff.
yeah, yeah, and it supports both scalar functions as well as aggregate functions, which is kind of cool because I would think the
Mhm.
aggregate functions performing well is pretty cool.
Yeah, completely.
Yeah. Nice.
And then
Okay.
also, I know you want to go to another question, but I think another feature I just really love on Spark is AQE, adaptive query execution. I think that's so amazing. It was such a good contribution, and that basically tunes the shuffle partitions sort of dynamically throughout the Spark job, and that is something that I think is, we used to have lots of issues where people are having bad performance. We're like, oh, just set your shuffle partitions to X,
Yeah.
and then it would solve it, but they just didn't know to do that, right? And it just does automatically. So love it.
That's interesting because it does relate to another question, but since you're on it, um, will using adaptive query processing, will that also help avoid shuffles that you could avoid if it's smart enough to prepare the data correctly or avoid the shuffling or no?
I think it probably could in some use cases. Like for instance, one thing that EQE will do is it will sort of, I think this might avoid shuffles, is it will set you up with a skew join
Mhm.
automatically. For instance, like if your data is skewed, it will sort of detect that and just automatically make it a skew join.
Oh,
In that case, I think it does do quite a bit on avoiding shuffles. I'm not 100% sure there, but yeah.
cool. All right, so I've got a little bit of a game on this next part where I want to say a particular technology within Spark, and your response can be always use this, like it's great. Sometimes use it, never use it, like run away, get away from it. And maybe if you have a comment, a description of why you think that way, I'll just kind of rattle them off and we can kind of.
Perfect. Let's go for it. I'm ready.
All right. So one I think I already have a sense of, but Apache Arrow.
Always love it.
Okay. Cool.
Right.
And by the way, I'm pretty sure on Databricks now it's automatically configured to be on by default because even when I did my book, it was. So that's cool.
Yeah. Spark 2 it wasn't. Spark 3 it is.
How about Spark R?
This is a good question because our use cases are, it seems like they're less. But if you need that one library that one academic published that does that one thing, you need to use R. So I'd say like between Spark R and Sparkly R, I always use Spark R.
Okay. All right. And Sparkly R then probably go to Spark R instead would be your answer.
Yeah, it's tough for me because I actually learned Spark on Sparkly R. And I have a soft spot for it. But I feel like the project has probably progressed quite a bit. But since Databricks doesn't own it, I haven't really kept up with it too much. And I love, I mean, I've tried pretty hard to see what's going on under the covers in Sparkly R, but the code was a little bit, it was like an onion. There's lots of little layers. So I haven't gotten too far with it.
Fair enough. Delta Lake?
Always use.
I figured that one. Okay.
Always.
Parquet?
Parquet is what Delta Lake is built on. So always, yeah.
Okay. Orc?
I never use it. Don't use it.
Yeah, it seems like if you needed it for some specific edge case, I guess.
Yeah, we have connectors so that we could read ORC if we needed to, but yeah, I think that's more of a Presto thing, if I'm not mistaken.
Okay. On Azure, ADLS Gen 2?
Oh, always, yeah. Yeah, that or AWS or GCP, sort of, data lakes.
Even if it was a small load, because ADLS Gen 2, I think is more expensive to use.
If it's a small load, I'd probably use blob storage.
Okay.
But S3, I'll always use that for sure.
JDBC.
I don't use that very often. It can be a little bit tricky sometimes, and it's not very fun to do because setting up the query parameters and stuff. So if there's a way I can avoid that, I usually will.
Okay.
Yeah.
And JDBC, to be honest, I mean, I think it's the only way if you're going to read an external SQL database in your environment. I don't know the way around it, but it's probably not the most.
There's ODBC, but that's kind of the same thing as JDBC. So yeah, yeah, unless there's some sort. Yeah, I guess so. I guess you're right.
Yeah.
Yeah, that has a monopoly.
So this I'm curious about Kubernetes as your underlying platform.
I think it's awesome. Kubernetes is great.
And Spark on Kubernetes is really working well.
Mm-hmm. I mean, Databricks is all sort of based on Kubernetes, from my understanding. That's how the auto scaling works.
Okay,
so
awesome.
Yeah.
Streaming.
I would always use that if I can, but it's definitely something where it's like batch or streaming. So there are very different use cases. So sometimes you just need to. You have a data set and you need to see what's going on. So it's exploratory. Other times you're streaming stuff. So
what about Kafka? Is that almost ubiquitous when you're doing streaming to use Kafka?
Not necessarily, because Kafka is sort of one source. So there's a few different ways you can bring data in. Kafka is a messaging service. So you can stream in messages with Kafka or sort of like the related services that are sitting on Azure, GCP, AWS, like for instance, like event hubs on Azure, for instance. But then you can also stream in data. So for instance, like you can have a queue coming from like a directory and you can have, you can stream the data in. So it's not synonymous, but you're going to be using streaming all the time if you're using Kafka.
All right. Also, this usually get a lot of questions from customers, and I don't really see a big difference. So I thought I'd throw it by you, but it's the using local database storage, and I think on an Azure, I know you can configure it, I believe, to use blob storage, or I think you can I know on HT Insight, I think on Databricks, you can configure it for ADLS under the covers. Is there a reason to avoid using local storage on Databricks as opposed to, say, some separate storage area and going to that?
I don't think so. Well, okay, there is one big one. So yeah, so just to clear up sort of the nature of the storage, I think you're talking about DBFS, right?
Correct.
Databricks file system. So that is basically on Azure, that's going to be blob storage. It's not going to be Gen 2. And then on AWS, it's just another S3 bucket. So it's just like anything else. The reason why you would not want to use it is if you wanted some sort of special permissions on it, right? So like basically, if you write something to DBFS, I believe everything just gets written as root there. So like anybody can be able to see anybody else's stuff.
Yeah.
So versus like if you have a storage account like on ADLS Gen 2 or S3 or something, you can set all sorts of stuff there.
Okay, yeah, good point. Okay. So this gets into an interesting kind of reverting back to the data warehouse. And I'll kind of backlay a little bit for people, make sure the question is clear. But one of the things that makes it a challenge on any scaled out platform that I see, includes Snowflake as well as Synapse, is that there's a lack of something that a single server-based SQL Server type thing would support, is the support for primary key constraints, foreign key constraints, things that enforce data integrity. So a unique primary key that's enforced across the cluster nodes, foreign keys, et cetera. And that's, I've looked kind of quite a bit on both the Databricks side and Snowflake, and they say like you can document it, but it won't enforce it. So that seems to me a bit of a problem if you need that kind of integrity. If you built it outside and you were just loading the data and it already had it, you'd be all set. But do you see any like solutions, workarounds, or anything that would kind of help get around that type of issue?
Yeah, this is a great question because basically a lot of people sort of that are traditional data warehouse users love their primary keys because each row is going to be unique, right? So it makes organizational issues a lot easier, right? But on Databricks, when you're dealing with things at scale, what's the one thing you don't want to do? You don't want to do a full table scan, right? You would hate to do a full table scan. So that's the one thing that is kind of important if you're doing these primary keys. So it's sort of going to be a paradigm shift that's needed if you're coming into sort of like at scale. Like Snowflake doesn't have primary keys. Databricks, like with the Delta, doesn't either. And the reason why is because we would have to take a significant performance hit to have those. So it's like, which one do you want? Primary keys that work natively, or do you want better performance? Most people say, well, we got better performance, right? That being said, you can always create your own sort of, way to get the primary key functionality. Popular ones are just figure out what the natural key is, right? Like the natural key is going to be either one or more columns that uniquely identify your rows.
Yeah.
And then you can just, if there's a lot of them or if it's convenient, you can just take a hash of those columns and then make that a new column. You can always do that. And then, for instance, if you're using merge with Delta, you can just you can add some sort of functionality so that it does something with that hashed column or whatever, or on those three columns that form your natural key.
Okay. I want to thank you for watching this segment of the video with Daniel Zafar, a deep dive technical expert software engineer for Databricks. Please continue to the next video where we'll get into more details. Until then, I'm pulling for you. We're all in this together. Thank you.